Okay, well, if you did the first one, Alabama, um, so solution for Alabama, let's see, A-L-A, Alabam. This is just 4 here and 3 other letters, so this should be 7 factorial, total of 7, and then I'm dividing by 4 factorial. So the answer is 7 times 6 times 5, so 210, right? 210 ways to arrange those linearly. And for Mississippi, for B, solution is if we have Mississippi, we have, let's see, 4 miss 4, 3, so 11 factorial, and 4 factorial for the S's, 4 factorial for the I's, and 2 factorial for the P's. Do we want to try to do that? I don't know. You can do that, right? Okay. So, all right. So what's next? Combinations. All right. So sometimes we want to count how many possible groups I can pick of a certain size from n distinct objects. Okay. So, the question is, this asks, so if I take NCR, which is called sometimes N choose R, and it's called a combination, this is equal to the number of distinct groups of size R from N distinct, now we're back to distinct objects. Okay. So suppose I have I want to just pick 2 people in the class to do something, and say I have example 12 people, 12 students, say, and I want to pick 2 to do some job, say to do an experiment. Well, there are 12 P2 orderings of the 12 of the first 2 of 12 students. So this is equal to 12 times 11 orderings of size 2. But this is the same as picking, this is double counting, because, for example, if I pick, say each student is given a letter, A through, or a number, 1 through 12. Well, then there's 12 possibilities here, right? And then for each, there would be 11 here. But that means that if I'm counting 1, 2 as a possibility, there would also be a 2, 1. And these are the same. So these are the same group. Right? So we have to divide by 2 factorial, by R factorial. Okay, so in short, the answer is N choose R, which we'll sometimes write like this, NR is equal to, I have N times N minus 1, down to N minus R plus 1. So this is R terms up here, okay, by the principle of counting. And now I have to divide by whatever this number is. Well, it's R. I have to divide by that factorial so I don't double count picking them in different orders. Okay, let me do it with a shorter example so you can see. So for example, suppose we have how many, so let's say how many combos, groups of size, let's just make this 2 from the letters A, B, C, D can we pick? Okay, well, I start with how many ways I can pick the first 2 from A, B, C, D. So notice I could have AB, AC, AD, BA, BC, BD. Now I have C, CA, CB, CD, DA, DB, DC. Okay, so this is when order matters. So this is 12 permutations. And that's just 12, that's just 4P2, right? Which is equal to 4 times 3. But now we have to see we're double counting here, right? I have an AB and a BA. Okay, so this goes with this. I have an AD and a DA. That goes with that. So for each, there are 2, right? They can be in either order. If this was picking size 3, there would be 3 factorial different orders. So I'd have to divide by 3 factorial. So the number of combinations, NCR equals NPR divided by R factorial. So this is 4 times 3 divided by 2 times 1, which is equal to 6, right? There are 6 different choices we could make. Okay. The formula is, up here I wrote it this way, but you notice it's important to note that n minus 1, this is one of the minus r plus 1, is just equal to n factorial over r n minus r factorial, right? This will just select these first r numbers. Okay, so for example, 7 factorial over 3 factorial is just equal to 7 times 6 times 5 times 4. So that's what this is saying. Okay. All right. So, hope that's clear. Yeah. Okay. Let's do another example. So example, say I want to please say there are 4 students in Econ 360 and say there are 12 Math 217. How many ways can I pick 4 students such that 2 are in Econ 360 and 2 are in Math 217? Well, this is just going to be 4 choose 2 and 12 choose 2 for the math, but then I have to multiply them by principle of counting. And that little multiplier is principle of counting. Okay, so I get 4 times 3 over 2 factorial times 12 times 11 over 2 factorial. And you see these cancel here, so you get 132 times 3, so that's 396. Okay, that's a lot of ways, right, for just that few number of people. Okay, one thing about the combinations is that we have an identity. It's pretty simple. is that n choose r, the number of ways to pick r from n is the same as the number of ways to pick n minus r from n. And the reason is because if I'm picking r from n, that's equivalent to excluding the n minus r that you don't pick. Most people can see that that's logically equivalent. So these, in fact, are the same. If we do this, calculate this for, say, 5 or something. So here, of course, r is between 0 and n. So to see it, a little example, suppose we have 5 choose 0. Well, I'm going to use the formula here. So this is n factorial over n minus r factorial, 5 factorial times r factorial. Now 0 factorial is defined to be 1. So this is 120 over 120 times 1. So this is 1. There is one way to pick nothing. Makes sense. Now 5 choose 1. Okay, this is 5 factorial over n minus 1, 4 factorial. So you see, this gives me the one way to pick 1. When I divide this out, this is that one slot that I'm picking. And now I have to take care of all the ways they can be arranged. There's only one way to arrange 1, so that's 1. So this is 5. This makes sense, right? There's 5 ways to pick one thing from 5 distinct things. Now 5 choose 2. This is, now I think here I'll write 5 factorial, 3 factorial. This quotient here gives me 5 times 4. And that's the ordered way, 5 times 4. But now I divide by the ways I can arrange those, 2 factorial, right? So I have 5 times 4 divided by 2, that's 10. Now, for the other ones, you don't really need to do it, right? I can go back up this way and you'll see they're the same. This switches with this, right? Because I have, this is n minus r and this is r. So these switch, so I get 5 factorial over 2 factorial, 3 factorial, and these just switch around. So this is the same thing. And this will be the same thing. How many ways can I pick? 4. This is 5 factorial over 4 factorial. Sorry, that should be 1 factorial there. That gives me 5 times 4 times 3 times 2, and now times 4 factorial, the way they can be arranged. And finally, this is equal to 5 choose 5. Okay, as you can see. Oh, you could prove it directly from the formula too. Should be clear. Okay, we got to stop. One more.